The three-chair demonstration is an assembly of three compartments. Each compartment has a small hole through which you can see the contents. In the back, the compartments are open. For the demonstration, you are invited to look through the hole in compartment 1. This is what you see. Next, number 2. And now, number 3. Now, let's go to the back and look in the compartments from this point of view. This is compartment 1. Now, look in number 2. And now, number 3. This is a chair, now viewed from above. What kind of motion do you see? These are not solid spheres changing position in space. They are balloons changing in size. This effect is obtained with the size-brightness apparatus. It has two operating levers. This one operates a bellows for the demonstration which you just saw. The other lever operates a rheostat for two lights used in 3 additional demonstrations. The two levers may be moved like this to increase or decrease size and brightness together, or they may be moved like this to put size and brightness in opposition. In practice, it's more convenient to get opposition by flipping a switch to reverse electrical connections and moving the levers together. In the back, you see the tubes which connect balloons and bellows. Here are the rheostat-controlled lights, one for each balloon. There are 4 parts in the complete demonstration. This is part 1, which you have seen, changing size. This is part 2. The effect is now caused by brightness changes only. Part 3. Now, size and brightness are combined and supplement each other. Part 4. Now, size and brightness are in conflict. At the overlay table, you see 3 groups of cards. The question is this. In each group of cards, which card appears to be nearest to you? Consider these groups first. In the left group, which card looks nearest? In the right group, which looks nearest? At the left, the bottom card really is nearest. But at the right, the nearest card is at the top. Now consider the group with the playing cards. Which looks nearest to you, the king or the 6th spot? The king is nearest. This becomes evident if you watch the playing cards while your point of view again moves to the left. bases of the card support rods provide another clue to the actual arrangement. This is a side view. Look at this man's hands. Are they normal and equal in size? What kind of path or track does this card follow? Let's watch this again. The path actually is straight, as is shown in this look-down view. Knowing the facts about these demonstrations has little or no effect on what you see. For example, this trapezoid is made of thin painted sheet metal. The sides can be compared by using these rulers, which are of the same length. You can see that this side is about 3 inches shorter than the opposite side. For the demonstration, the trapezoid is mounted on a small electric motor which rotates the trapezoid at a constant speed and in one direction. Is it swinging back and forth, or is it rotating? It's rotating, as is shown when looking from above. Even so, the trapezoid can be deceptive. But rotation is evident if you constantly relate the trapezoid to the background. Interesting effects are obtained by attaching various articles to the trapezoid. but cube and trapezoid are rotating together. Notice that tube and trapezoid are both rotating. And then watch this. Does the tube bend, or does it cut through? Changing the angle changes the effect. Changing the angle between card and trapezoid changes the effect. The basic principles of the trapezoid design can also be applied to other shapes. For example, the trapezium. You can tilt it like this and lock it at a selected angle. Like the trapezoid, it rotates in one direction. Changing the tilt changes the effect. A circular cam causes a cycle of changing effects. When you install the cam, the tilt changes continuously while the trapezium rotates. The plane of the trapezium is always vertical. Again, rotation is evident if you constantly relate the trapezium to its background. This is a distorted room, a small one. Sit right here. Now place this patch over one eye. And put your chin in position on the crossbar. This is what you see. Now put the pointer in this back corner and try to hit that back top corner without touching the back wall. Let's change this a little. This time, try to hit the bottom corner. Now we'll place a V-shaped trough across this room. Which way does it slope? The principle of distorted room design permits more than one kind of model. For example, this is another room which appears rectangular when viewed from the right position. And this is a full-size distorted room, as large as a small dining room. To see this room, walk up on the platform and look through a hole in the door. Examine the room in detail. The finish is unusually simple, but otherwise, do you see anything unusual? Does the room look normal? Are floor and ceiling parallel? Is the floor horizontal? Look at this chair. It's a very unusual piece of furniture. Now, let's see what this room really is. Note that the floor slopes about 30 degrees. Let's go around back and look in a window. But even though you know what the room really is, when you look at it from the right spot, it still looks like this, and you still see the men strangely distorted in size.